My name is Varadan. I represent the Biomedical Engineering Group in Applied Mechanics and Biomedical Engineering Department. So we have this new program that we call as Instrumentation and Biomedical Engineering. Why now? Why this? Because biomedical engineering at IIT Madras as part of the applied mechanics department has been in existence for the last 52 years. Since 1973 we've been part of the applied mechanics department. Why do this now? Because there comes a time when your time has come. Like they say, I kept telling my colleagues, I lead the biomedical engineering group. I kept telling them that no one can stop an idea whose time has come. That time has come. Why? Because it turns out that biomedical engineering in the next 5 years is in India, I'm just talking about the Indian market, is the $30 billion opportunity market. And it turns out that 80% of these medical devices are being imported. And when you say imported, so that means that we are actually making the other 20% is what we would think. So what are those 20%? We dig a little deeper and try to find what is the 20% of the things that we make. So we do, Indians, we do make some 20% of things. What are those things? Can anybody guess what are the medical devices that we make in India? Any medical device you would have seen, right? Medical devices that we make in India. Those 20% includes things like bandages, sutures, blood bags, stretchers, linen. These are not medical devices, but for some classification purpose are classified as medical devices. What to me as a biomedical engineer constitutes a medical device is something that involves core engineering in it. Has an electrical instrument that measures or provides treatment. That to me is a medical device, and that is the 80% opportunity, and that almost that entire electromechanical imaging instruments, big instruments, small devices, wearables, everything is imported. That's a huge opportunity, and the government is interested in reducing this import burden. And we, as the leading engineering institute in the country, thought this is the time for us to rise to the occasion and build this program. And we put the student at the center of our world when we designed this program. So this is essentially an electrical or circuit-oriented engineering branch that focuses on biomedical engineering applications. So this is the reason we call this as instrumentation and biomedical engineering. It's not biology per se. So the students learn enough biology or physiology as we call it, or regulatory affairs and safety protocols course as part of your program. And this, it turns out, because unlike, for example, this mic, it has some standards, but the moment you are going to put a therapeutic device on a human or a diagnostic device on a human, the standards that it needs to go through are far more rigorous. And we said, yeah, we are offering that course as an elective. And then they got back to us again and saying, no, we want this to form a core part of your program, and we modified this. And this is critical. Why am I mentioning this? Professor Mahesh also mentioned about that program. Both these programs, CEM program and the IBME program, has gone to the industry and got that sort of, I won't say validation. We have iterated the program curriculum based on the feedback that we have received from the industry. So by the time the student graduates, they are already industry ready. They are already ready to go, because we, for example, now then we modified the program to include this regulations and safety standards in medical devices as part of the core curriculum. Why? Because the industry says they want this. It is not about what I want to teach. It is about what the students will be ready with when they graduate. So this is our instrumentation biomedical engineering program. We have a couple of videos. I think Nikhil and the team will share with you all the video links and the PPTs with you, which you can watch at your leisure. That contains the details. So that's approximately what it is. So what we are looking at, there are three possible pathways that we have aimed for that we are looking at for the student. Like he says, what will the student be when they graduate from this program? That's the big question, like the pen picture of the graduate. First is work in biomedical engineering companies such as, for example, Siemens Healthcare, Philips Healthcare, GE Healthcare, and other such huge companies that build, say, for example, MRI machines, ultrasound machines, and this. Second, and this is important for us, for India, this is important, build medical device startups. because we have a $30 billion opportunity. And I'm looking at, like Arvind Srinivas built Perplexity AI, like Swapnil and Tarun built this Aether. Aether scooter was built by our students. I am looking, is there somebody in this room who can solve the diabetic foot problem for the country? It has to be somebody from this room. It has to be from, say, the 2025 newly joined students of Instrumentation Biomedical Engineering. The diabetic foot problem. The diabetic foot problem is this, in case you didn't know, this is the problem where people who have diabetes in slightly more advanced condition, some of the people, they are not able to feel their foot. When they keep the foot down, it feels as if they are walking on a mattress. This is problematic because when there is a stone or a harmful object, they place their foot over that and it hurts them and they won't feel the pain. Pain is actually good because if there is pain, you will remove your leg away from it because they don't feel the pain. They continue to keep the foot with a high pressure and the bleeding won't stop easily for diabetics. The wound won't heal. Sometimes it leads to amputation. It's a huge problem. Who is going to solve this problem? It's an uniquely Indian problem. India is the diabetes capital of the world. We need to solve this problem. And remember, because we are 1/5 of the world in terms of population, if you have solved a problem for India, you have solved the problem for the world. So look at the big picture. Let's not, the way I would say that is, it's not about the pay package. It's not about 1.5 crore, 4.5 crore pay package. Think really big. Build a 1,000 crore company, diabetes foot. Or like I joke with my students, if only, we find a way to put people to sleep, that's a multi-billion-dollar opportunity. You're thinking, really, is that such a big deal? It's a huge deal. People are not falling asleep these days. I keep joking that, you know what? Whenever I speak, my students are asleep. If only I could make a device that exactly mimics what I do in class. I will be as rich as Elon Musk. And my students laugh. No, so there is a difference, right? Like you have this digital twin. If you could make a digital twin of me that speaks and put you to sleep, nicely sleeping. It's a huge multi-billion-dollar opportunity. It's a different point that, we created this problem. We created the cell phone and we are watching the cell phone, so we are not sleeping. That is all fine. But can you make a device that could induce sleep? It's a huge multi-billion-dollar, problem. There are devices that track sleep. That's different. I'm talking about, can you put people to sleep? It's not like, I have a 4-year-old who I put to sleep. Even now I put her to sleep. But how do you put I'm 44 years, how do I put a 44-year-old to sleep? It's a huge problem. And problems of that scale, that magnitude. Look at, building a 10,000 crore, 1 lakh crore company. Big thing. Let's not worry about the 4 crore pay package. That's the other opportunity. The other is in terms of research. One is working for the companies. 2 is building your own startups and entrepreneurial opportunities. 3 is, getting closer to the sciencey part of this, doing research and that, doing a PhD and then choosing your career path, maybe academics, maybe other things. So that's IBME for you. So this is essentially electrical engineering applied to biomedical engineering problems, medical problems. And the amount of medicine, biology that is required is just enough that the students can solve the problem, but not too less that they don't understand what they are doing. So a regular electrical engineer cannot do this, but our students will be able to do this. And of course, our students will not be like doctors who know the physiology at depth. They won't be knowing that. So it's like there is just enough this. So questions or this about this program I can answer. Yes, sir, please.
Is this program different from the biotech program which is there?
So, excellent question. The question is, how is this program different from biotechnology program? For what it's worth, it's useful for me to speak about the other biotechnology, other bio programs in IIT Madras. There are 3 other bio programs at IIT Madras. The first is BTech Biological Engineering. That is the first one. The second one is BS Biological Sciences. The third one is called as BS Medical Science, and ours is Core Engineering. So fundamentally different. That's biology and still deep science. That is not to put them down. That is still deep science. It's a different department. That is the biotechnology department. It's a different department, different program. They are focused on, and for what it's worth, that is a valuable program. For example, COVID was solved by biotechnologists who knew virology and immunology. So there are applications for all these in different fields. Yes. Question? Any other question? Did I answer that, sir?
Know about bioinformatics is also there, na? The branch bioinformatics.
Bioinformatics, as of now, is not part of our program, nor is it a part of the biotechnology. As in, there is no bioinformatics program. Branch is not there. A branch or a program is not there. But bioinformatics forms part of the biotechnology program. More biotechnology because they collect data at the cellular subcellular level, which they then process using advanced algorithms, which they call as this. We have a different program, different course in our program that we call as AI for health care or digital health, where we also collect data, but not at the cellular level, at the macro level, like blood pressure, like Professor was saying, that there will be a digital twin of you, and that will be a reality 10 years from now. There will be a digital twin of the human that will essentially say, I mean, what is your blood pressure, what is your temperature, and that's being monitored. That could very well be a reality. Yeah. So bioinformatics is more computational aspects of biotechnology used at the sub millimeter level, so small scale. As of now, that is how what we do. We call as health informatics. So we work with several humans and we try to make models at the population level, for example, which we call as AI in healthcare or digital health. So so we work with things that we can see with our own eyes. Yes. In biotechnology, biology will be deeper, and there will be several courses that will enable them to do. And mathematics will be lesser. Ours is a math heavy program. There are 5 math courses. So because this is core engineering, mathematics will be heavier in our program. Like any other engineering program, like electrical engineering will have math heavy, mechanical engineering will have math heavy, or biomedical engineering will also have math heavy.